All right, let's look at molecular geometry. Radio. All right, in the case of molecular geometry, what we're looking at is exactly what the word is, geometry. Oh my gosh, geometry is like looking at shapes of molecules. All right, and if you already copied down the notes, what we're going to start with is just the molecular geometry. Actually, the first page. And what you have is you have AX, and we're looking at the molecules carbon monoxide, hydrogen chloride, or bromine, and what that molecule looks like. Well, first of all, if we look at the diagram of it, this is what the diagram looks like. All right, so we got a hydrogen bonded to a chlorine, all right, and we got this bond in between, covalent bond in between. And I labeled down here the hydrogen we're going to represent with the balloon, and then the chlorine we're going to represent with a knot. So I basically got one balloon, all right. So this right here, this is the hydrogen, and then where my finger is over here, that's the chlorine molecule. And what I end up with, and this one, the first couple are really kind of boring, not very exciting, because I got really two dots or two spots. Well, what's the distance between two spots? Is called a line. So this molecule is considered to be linear. It makes a straight line molecule. All right, so no matter where I hold it, it's going to be a straight line molecule. And remember, this is the chlorine where my fingers are. The balloon is the oxygen. All right, if we go to the second one, and the second one happens to be, I have diagrammed carbon dioxide. Flip that one. There we go. So carbon dioxide is going to look like this, where I got two double bonds. So I got my carbon in the center, and I got two oxygens on either end. The balloons are going to be the oxygens. The knot that's in the middle is going to be the carbon. All right. So I take two balloons. Oops. All right. So if I take the two balloons and I hold them together at the knot, all right. So I end up with. Whoops. I end up with this. All right. So again, this is one of the oxygens. This is the other oxygen. And where my fingers are in the middle, that's the carbon in the center for carbon dioxide. And what we end up again with is we end up with this straight line molecule. It goes straight across, and it's considered to be a linear molecule. If I hold it straight up and down, same idea. It's still a linear molecule. It goes straight up and down. All right. So again, not a real exciting molecule. But let's go to the next one, which is BCl3. And BCl3 looks like this. So there's BCl3. So we got a B in the middle, and then we got a Cl on the outside coming out on each of the three sides. So the balloons are going to be the Cls. Put these together. Okay, and I need one more. All right, so I end up with this. All right. Now, if you notice on this, notice it's flat. All right. And also, if I hold it this way, notice it's got three lobes that stick out. Now, again, I want to point out where the knots are in the center. That's the B. That's the boron. And each one of these on the outside, that's a chlorine molecule. Now, don't get this mixed up with way back when we were talking about the electrons and we did orbitals. Now, this is different. Now we're going up to the atoms, and each balloon is an atom of chlorine. The knot in the center is the boron. Well, again, notice it's got three lobes. All right, so we consider that to be trigonal. And then notice that it's flat. So if I hold it this way, notice the molecules are flat. And we consider that to be planar. So this is a trigonal planar molecule. That's what BCl3 ends up looking like. All right, now let's go to the next one, which happens to be four balloons. So I need another blue balloon. Stick him in here. Now let's see if we can get. All right, so this happens to be methane, which is the stuff that comes out of the gas valves. It's probably what you use to heat your house if you live in and you have natural gas. Okay. Now I drew this one a little bit differently because this is the way, if you went and took this in college, this is how they're going to teach it to you. And it's really, really confusing. They try and teach you 3D on a 2D piece of paper. So you got the carbon in the middle. That's going to be my knot in the balloon. And then we have four hydrogens. Each of the hydrogens is going to be a blue balloon. What they try and show is one hydrogen going up, and then you got a hydrogen that's going back on the paper, another hydrogen going back, then you got this other hydrogen in the middle. He's supposed to be coming forward. That's why we have these weird triangles. This one, because it's wider, that means it's coming towards you. These ones where they're pointed, those are going away from us. And it's really confusing to look at this, but this is the way they're going to teach it to you if you go take chemistry in college. Well, the reality is this is what it looks like if we look at it as a balloon. Now, I want you to notice it's still got the 3 lobes, all right? But then we've also got one that sticks up on the top, all right? And also, if you notice, it's not planar anymore. Right? If it was planar, these 3 at the bottom would be flat, but really we got this one at the top that's pushing all 3 of these guys down. All right, so now this one isn't going to be a kind of planar molecule. What we do have is I have a triangle shape right here, and then if I turn it, then I have another triangle shape here. If I turn it again, I have another triangle shape, and then if I flip it up on the bottom, I have another triangle shape. So I really have 4 sides to this molecule. So we consider it to be a tetrahedron. Tetra meaning 4, right? Hedron being a shape. So it's a tetrahedron. But that's this molecule, and that's what methane happens to look like. And again, in the center, the knot in the center, that's the carbon. Each one of the blue balloons is a hydrogen molecule. All right, so now let's go with 5 balloons. We'll see if I can get it to stay together without all falling apart, because that's what they commonly do sometimes, like that. So we'll do this again. And the great part about doing this with balloons is that the balloons kind of make the shape. They do exactly like the molecules do, and that is, once you get them kind of like knotted together in the center, then they just go together and make the shape the way it's supposed to be. The fun part is trying to get them to hold together without all of a sudden popping all apart. I'm just trying to twist them, because then I want to be able to take them apart when it's all done. I'm going to pause for a second, and I will have this done, and then I'll show you